Okay, Chapter 6. Chapter 4, we looked at elements and the periodic table. Now in Chapter 6, we're going to be putting these elements together and making compounds. So we'll learn how to name them, how to write the formulas for them, how to put them together as molecules and learn about their shapes. And then in Chapter 7, we'll go ahead and look at reactions and how to change these compounds and react them together. So we're getting pretty deep into things over here. This first part is just a review. The number of valence electrons that an element has, remember, can be told by its column on the periodic table. Remember, the noble gases have a complete outer shell with 8 valence electrons in their outermost shell. And then the alkali metals start off the next shell with just 1 electron. So 1 valence electron in this family, 2 in this family. The transition metals are going 1 level down to fill up the d orbitals, so generally they still have 2 in their outer shell, and then we have 3, 4, 5, 6, 7, and 8 valence electrons for these elements. This number of valence electrons determines the charge on the elements that have a predictable charge. So again, this is something we covered in Chapter 4. Make sure that you know how to figure out the predictable charge on elements that have a predictable charge. And a lot of the compounds we're going to be dealing with in this chapter are ionic compounds. So these two elements will form ions, and then the positive and negative ion will be attracted together and bond together to form an ionic compound. When we write the formulas of these, they're written with the metal first. We know from Chapter 4 which part of the periodic table has the metals. So let's go ahead and try to write the formula for each compound. Remember, the number of each element is written as a subscript. Okay, let's try this first example. We have oxygen and iron. So hopefully in Chapter 4 you've been learning what these elemental symbols are for the commonly used elements that we have to know. If you are behind on that, then definitely use those flashcards. Make your own flashcards. You do need to be able to look at the word iron and know that the symbol is Fe. Also, we should know that iron is a metal, so we're going to write that one first. If there's 2, we'll put a 2 as a subscript. And then oxygen is an O, and there are 3 of those, so we'll put the 3 as a subscript. That's how we would write the formula. Zinc is our metal. We're going to write that one first. If there's only 1, we don't need to put a subscript. Then chlorine is Cl, and if there's 2, we'll put a subscript here. Remember, these elements that are written with 2 letters have a capital and a lowercase. So don't be writing this. That's not correct. So gold is our metal here. We're going to write that first. If there's 1, we don't need a subscript. And 3 fluorines would be next with F as the symbol. Very soon we are going to be learning about some polyatomic ions. So this is an ion that has many atoms in it instead of just 1 atom. Most of the time these are anions. We do have 1 cation we're going to learn, but most of these are anions. And the anion itself has a group of atoms in it. So for example, here is our anion here. We have magnesium ion. Magnesium, you'll remember, forms a +2 charge. And then we have 2 of these OH ions. They're called hydroxide. So we have an OH and an OH. Each one of these has a -1 charge, each group. So when we put these 2 groups together, that's -2. And then we put that with the +2. So altogether, our compound has 1 magnesium and 2 hydroxides. That means there's 2 oxygens and 2 hydrogens here. So when you read this formula, remember that what's in the parentheses is what is being doubled by this subscript. So not only are there 2 hydrogens, there's also 2 oxygens. We're supposed to be listing the number of each element, so let's do that. This compound has 1 magnesium, 2 oxygen, and 2 hydrogen. This one over here, the aluminum does not have a subscript, so there is just 1 aluminum. And then there's 3 of this nitrate group. Let's draw these. Al, NO3, NO3, NO3. 1 aluminum and 3 of the NO3 group. So that makes 1 aluminum, 3 nitrogen, 1, 2, 3, and 9 oxygen, 3, 6, 9. So it's kind of like you have to distribute this 3 to everything that's in the parentheses. 3 times the 1 nitrogen makes 3 nitrogens. 3 times the 3 oxygen makes 9 oxygens. This one over here has 3 calcium, so there is a subscript on the first element this time. 2 times the 1 phosphorus makes 2 phosphorus. 2 times the 4 oxygen makes 8 oxygen. So this last compound has an example of our one and only polyatomic cation. That's why this is listed first, because it's the positively charged polyatomic ion. And then we also have a negatively charged polyatomic ion. So we'll be catching up with that, but for now we should be able to figure out the number of elements. 2 times the 1 on nitrogen gives 2 nitrogen. 2 times 4 hydrogen gives 8 hydrogen. The sulfur is just 1, and the oxygen is just 4. So we are going to be taking a closer look at these diatomic molecules this chapter as well. Hydrogen exists as a diatomic molecule, also nitrogen, oxygen, and then all of the halogens, so fluorine, chlorine, bromine, iodine. So we'll be looking at how these are connected together as molecules a little bit later in the chapter. One of the things that we're doing in this chapter is learning how to name compounds and draw the structure of compounds, and we are going to do that differently for things that are ionic and things that are molecular. And so one of the first things we need to know how to do is recognize whether a compound is ionic or molecular. If something is ionic, that means it's made up of charged things, a positively charged cation and a negatively charged anion. The cation can be either a metal or our 1 polyatomic cation, ammonium, which is NH4 with a +1 charge. An anion will be either a nonmetal or a polyatomic anion. If we have a molecular compound, then we don't have anything that can have a positive charge. Nonmetals, when they become ions, are all negatively charged. So if the entire compound is made up of nonmetals, then it is probably a molecule. It is probably made by elements that are sharing electrons rather than having charges. So for this problem, let's go ahead and try to figure out whether the compound is ionic or molecular, and then we can do a little bit of practice listing each element and the number of each element so that we know how to read these chemical formulas and their subscripts. All right, we have chromium, which is a metal, the cation, and the nonmetal being the anion. This is ionic, and it has 2 chromium and 3 oxygen. This one has phosphorus, which is a nonmetal, and chlorine, which is a nonmetal. So these can't be ions because then all the charges would be negative and there would be nothing positive inside this compound. So this is a molecule or a molecular compound, and it has 1 phosphorus and 5 chlorine. This one also has all nonmetals in it. There's no possible cation here, so we have to have a molecule. And this one has 6 carbons, 12 hydrogens, and 6 oxygens. This one we do have a metal, something that's able to form a cation. And then even though you might not recognize it yet, we have a polyatomic anion. So this is ionic. It has 2 sodium, 1 carbon, and 3 oxygen. This one has a metal and a nonmetal. It is ionic. It has 1 magnesium and 2 bromine. This one has a metal and a nonmetal. It is ionic. It has 2 potassium and 1 sulfur. This one has a metal, aluminum, and a polyatomic ion for the anion. So this is ionic. It has 1 aluminum, 3 nitrogen, and 9 oxygen. This one has lithium metal with phosphorus nonmetal. It is ionic. It has 3 lithium and 1 phosphorus. This one has a metal and a polyatomic ion, so that is ionic. It has 1 barium, 2 oxygen, and 2 hydrogen. Okay, so hopefully you are already starting to learn the 52 common elements that are in the Quizlet flashcards and on the periodic table. We also need to learn these 26 polyatomic ions on page 48 of our note packet, and then the names of these acids as well. So these are common acids that are named a little bit differently from the naming rules that we're going to learn. So the names of these just need to be memorized. When I was learning these, the names of the acids and the formulas of the acids actually helped me learn what the polyatomic ions were, so that is one thing to try, but we need to learn the things on this page. I have 5 of them in bold. These 5 in bold are the most common ions, so they're a good place to start. And also I'm going to show you how you can get from these 5 common ions, if you memorize them, you can actually expand and know several more of the ions. So these have some Quizlet flashcards made up as well. You could make up your own, or you can use the ones that I have linked on Canvas. But these have to be learned. Let's see if we can find some patterns that make it a little easier to remember the polyatomic ions. This doesn't cover all the polyatomic ions, but it could help with some of them. The first ions I would start with are the 8 ions. The 5 that are in bold on your chart: nitrate, sulfate, phosphate, carbonate, and chlorate. The way I originally learned these was by using the acids. I memorized the names of the acids. Nitric acid was HNO3, sulfuric acid H2SO4, phosphoric H3PO4, and carbonic H2CO3. Each of these H's is hydrogen with a positive 1 charge. So if nitric acid has 1 H with a positive 1 charge, then the NO3 ion has to have a negative 1 charge. So that is nitrate, NO3 with a negative 1. 2 hydrogens. Sulfuric acid has 2 positively charged hydrogen ions, and so the SO4 ion must have a negative 2 charge to be able to make sulfuric acid with overall 0 charge here. So sulfate is SO4 with a negative 2. So since phosphoric acid has 3 positive hydrogens in it, the PO4 ion must be negative 3 charge. So we have phosphate being PO4 with a negative 3 charge. And so forth. We have carbonate, CO3 with a negative 2 charge. Chlorate, I don't have from the acid, but it's ClO3 with a negative 1 charge. There's another mnemonic to try to remember these 5 ions. It doesn't work for me, but some people really like it. If you want to do a search on Nick the camel eating clams in Phoenix, something like that. So you can try searching for Nick the camel eating clams, and what that does is just helps you remember the formulas and the charges for all 5 of these ions. So however you can memorize them and remember them, that would be really helpful. These are very common, so even though you might be thinking, oh, that's only 5 out of the 20 that I need to know, it's probably close to half of the ones that you'll need to use in the problems, even though it's not half of the chart. They're very common, so definitely start here. If you're feeling overwhelmed, just think, well, at least I can get these 5. So definitely start there. We need to have those remembered. Once you have the 8 ions, then you can make the corresponding ite ions. The way you do the ite ions is remember that they have the same charge, but they have 1 fewer oxygen. So Nitrite is like nitrate, but it has one fewer oxygen. It has the same -1 charge, NO2 with a -1. Sulfite would be SO3 with a -2, so the same charge, one fewer oxygen. Phosphite, the same charge, -3 charge, one fewer oxygen, PO3 with a -3 charge. There isn't a carbonite one, but chlorite is still a -1 charge and 2 oxygen. Then there are some other ions that have hydrogen in front of the ion. So hydrogen sulfate or bisulfate. So you could either put hydrogen or bi in front of it. And to do this, we're going to add a hydrogen ion. So we're going to add a hydrogen atom and a +1 charge to it. We're not going to do this for nitrate, because if we add something with a +1 charge to the nitrate, we don't get an ion anymore. What we get is just nitric acid, and that is not an ion. You still have to learn that, but it's not an ion. So we're not going to do that one. So for sulfate, we can make the hydrogen sulfate ion, also called the bisulfate ion, by adding an H+. So we're going to add an H to the front here, HSO4, and then when we add a +1 to a -2 charge, we come out with a -1 charge. Then we have hydrogen phosphate here. You can call it biphosphate, but hydrogen phosphate is a more common name. So HPO4, we're going to add an H, and then we add a +1 to that charge, giving us a -2 charge. You can call this hydrogen carbonate, but for this one, the more common name is bicarbonate. So we'll add an H, and then we will add 1 to the charge, making the -2 into a -1. We have the same issue with chlorate, that if we add a hydrogen with a +1 charge, we won't have an ion anymore. We would just have chloric acid. So we're not going to do it with the chlorate. We do have another one on our list that is dihydrogen phosphate. So if we add another hydrogen to this phosphate, and we have 2 of them, so if we add another hydrogen, we will have 2 hydrogens, and then the charge will be increased by 1. It'll go up by 1, becoming a -1 charge. So since we still have a -2, we can do another hydrogen onto the hydrogen phosphate. We can't do it with the hydrogen sulfate or the bicarbonate. And then there's one more thing we can do with the chlorate and chlorite over here. We have a perchlorate ion and a hypochlorite ion. So from chlorate to chlorite, we went to 1 fewer oxygen. Hypo is a prefix meaning very low. So if you are hypoglycemic, you have low blood sugar. If you are hypotensive, you have low blood pressure. So this is low, and so it's lower than chlorite. So we have fewer oxygens here than we do in chlorite. We're keeping the same charge all throughout here. So hypochlorite is the ion that only has 1 oxygen. So this is a ClO. So it's a capital C, small l, and a capital O. So this is not an I. You can put it in cursive. And then the other prefix per is like hyper. Hyper is when you have too much of something, maybe too much energy if you're just hyper. Hypertensive means you have high blood pressure. But instead of saying hyper, we're just saying perchlorate, which means it has a high number of oxygens. So we have 1 chlorine and 4 oxygens with a -1 charge for that particular ion. So from learning these first 5 common polyatomic ions, we've increased it to knowing 15 of the polyatomic ions. So it looks like our polyatomic ion list has 26, but we've made a good start starting with 5 and getting to 15 by following this pattern. Oh wait, one more, I'll get us up to 16. I forgot the bisulfite or hydrogen sulfite ion. So that is adding a hydrogen to sulfite, giving us HSO3 with a -1 charge. So now we have 16 out of the 26 falling into a pattern. So let's take a look at making the formulas of ionic compounds. And you'll start to see why we need to know some of those polyatomic ions. So the procedure for writing the formula of an ionic compound is to write out the cation with its charge, write out the anion with its charge, and then figure out how many of each you need to make a formula with an overall neutral compound. So overall the charge should be 0. Let's do a few examples. I'll do the whole table. Whenever you think you've gotten the hang of it, you can pause and try to do the rest on your own. So the cation for potassium is K, and if you look where it's located on the periodic table, it's an alkali metal. It has a +1 charge. Bromide is the element bromine when it has a charge. So the anions, when we name them, you replace the ending of the element with this IDE ending. So bromine becomes bromide when it has this -1 charge. One of each will do fine, making a compound with the overall 0 charge. So the formula for potassium bromide is just KBr. The metal cation comes first and then the anion, and that's how you write the formula. Calcium is Ca with a +2 charge. It's an alkaline earth metal. Chloride is a halogen. So this time, 1 calcium and 1 chlorine will not add up to 0. We actually need another one, another chloride. So when we write the formula, we're going to write it with 2 chlorines and 1 calcium. The formula does not have a charge written on it. Overall, this formula is 0 charge, so we are not going to write the formula in this column. This is the answer. This is the final answer. So if you can get to this formula skipping over these first 2 columns, eventually you might be able to do that. That's completely fine. These columns are just to help you out, and having the charges here I think is helpful. So lithium and oxygen. Oxygen becomes oxide when you give it a charge. Lithium is +1, oxygen is -2, so we need more lithium to make 0. So there's 2 lithium and 1 oxygen. Barium is a +2 charge. Sulfate. So when you see these IDE endings, a lot of times, most of the time, that's going to mean a single element with a negative charge. There are a couple of exceptions. If you look at your polyatomic chart, there are some IDE endings that are polyatomic as well, but they're pretty obvious that those are not single elements. Like hydroxide, there's no element hydrox, so you're not going to get confused there. So if you see an IDE ending and the beginning shows you that it's just one element, we have just one element, oxygen, with a negative charge. This one, sulfide, would be sulfur with a negative charge. Sulfate is one of our polyatomics. A lot of the polyatomics have ate or ite as the ending. So sulfate is a polyatomic ion. That's why we need to learn these. It's one of the common ones, the ones in bold. SO4 with a -2 charge. So if you don't know that, you're not going to be able to solve this problem. But if you do know that, then you can see that 1 barium and 1 sulfate would link together to make a 0 charge compound. So sodium is here. Bicarbonate is another one of our polyatomic ions. It's HCO3 with a -1 charge. And so one of each of these works out just fine. Sodium bicarbonate is the formula there. Copper 2 is one of our variable charge elements. Copper has a variable charge. That's why we need this 2 to show us what the charge is. So copper 2 is the type of copper that has a +2 charge. Sulfate is again SO4 with a -2 charge. So copper 2 sulfate would just be 1 copper, and 1 sulfate together. Aluminum has a +3 charge. Nitrate is NO3 with a -1 charge. So we're going to need 3 of these to balance out aluminum's +3 charge. So we're going to put that in parentheses and then put that there's 3 of those. You need those parentheses because if you don't have it, it's going to look like there's 1 nitrogen and 33 oxygens, and that's not what we have here. We have 3 of the nitrate group, 3 nitrogens and 9 oxygens. Okay, I had to scroll up a little bit so I could finish the table. We got silver. This time we have sulfide, not sulfate. This is the actual element sulfur with a -2 charge. And so we would need another silver, and this would be written Ag2S. Gold is a variable metal, so we need that 1, that Roman numeral 1, to show that it's gold with the +1 charge, because gold doesn't always have a +1 charge. However, if it does have a +1 charge, we will need 2 of them to go with the 1 sulfide ion. Nickel 2 has a 2+ charge. Oxide has a -2 charge. So 1 of each works out okay. Iron 3 has a +3 charge. Oxide has a 2 negative charge. So this is not going to work with a 1-to-1 combination. We're going to need more oxide. This still is not good because now it's 2 negative. Now we need more iron. And this still needs more oxide. Okay, so now we have a +6 over here and a -6 over here. So if you remember from fractions, finding the least common multiple, so 2 and 3 can both multiply eventually to get you 6. So we can take 3 of the 2's, 2 of the 3's, and that will even out. So I want to point out that these Roman numerals match the charge, not the subscript. A lot of times students are trying to match the Roman numeral that they see in the name to the subscript. Iron 3 oxide does not have 3 irons in it. It has 2 irons in it, but those irons have a +3 charge. Nickel 2 oxide does not have 2 nickels in it. Gold 1 sulfide does not have 1 gold in it. So don't try to match it to the subscript. So here we have magnesium with a +2 charge. Nitride, this is not nitrate or nitrite, this is nitride, which means it's just the nitrogen with the -3 charge. Again, 2 and 3, we're going to have to get up to 6 to have these match. So we're going to need 3 of the magnesium, 2 of the nitrogen, and that will get a 0 charge overall. Tin 4 oxide, we have tin with a +4 charge and oxygen with a -2 charge. So we're going to need another oxygen here. So that would be our formula of tin 4 oxide. Cobalt 2 is cobalt with a +2 charge. Be really careful to write cobalt with a capital and a small. If you write capital and capital, we have carbon and oxygen. This is not cobalt. So we have nitrate. This is one of our polyatomics. NO3 with a -1 charge. We're going to need 2 of those to balance the cobalt. And so that would look like this, 1 cobalt and 2 nitrates.